Okay, so in this class, we're going to quickly review the unit circle again, because you can never have the unit circle done too many times. For those of you that love the unit circle, and those of you that hate it, once is too many times. And something about coterminal angles. So let's start by drawing the first quadrant of our unit circle. Okay, so we have, of course, a circle that goes around, and this would be the positive first quadrant where all the x's and y's are positive. So the first thing we have to do is put in our little points. So we have a 0 point, we have a 30-degree point, we have a 45-degree point, we have a 60-degree point, and we have a 90-degree point. So these are all the points that we need to find our coordinates and usually our radian angle measures for. So let's do radian angles first. This is, of course, 0 radians. We haven't gone anywhere. It's also 0 degrees. Sorry, I forgot that one. 30 degrees. If you divide 180 by 30, we get 6. So our first angle is pi over 6 in radians. If we divide 180 by 45, we get 4. So pi over 4 radians. And if we divide 180 by 60, we get 3. So pi over 3 radians. And then if we divide 180 by 90, we get 2. So 90 degrees is pi over 2 radians. So we have a 6, a 4, a 3, and a 2 as our denominators for your first quadrant radian angle measures. Now, because we have a unit circle, that means all of these have a radius of 1. And special right triangles, this is now a 30, 60, 90. Okay? So we have an x-coordinate, or rather a y-coordinate of 1/2, because this is the short side of your 30, 60, 90, and the short side is always half the hypotenuse. So this is the y side, it's the vertical side. And the x, or your horizontal side for our 30, 60, 90, is the long leg of our triangle. So it's the short leg 1/2 times the square root of 3. Okay, so it goes root 3 over 2 is the x-coordinate, and 1/2 is the y-coordinate. Now there's a great little pattern that we can establish for this stuff. So I'm not going to do anything else, but I'm going to use the pattern because it's more fun. So in the x-coordinates, we count down. So we have root 3 over 2, and then root 2 over 2. And then at 60, we have root 1 over 2, which is just 1/2. And in the y-coordinates going back down, they also count down. So we have root 3 over 2, and then we have root 2 over 2. And here you see we already have 1 over 2. So there's wonderful patterns going on here with the x's. So we have root 3 over 2, root 2 over 2, root 1 over 2. And then the y's go root 3 over 2, root 2 over 2, root 1 over 2. Wonderful, wonderful patterns, so that we don't have to calculate every stinking time what these coordinates are. And of course, here at your positive x-axis, you have the 1, 0, and at the positive y-axis, we have 0, 1. Okay, so here's the first quadrant of your unit circle. Hopefully you can do that twice as fast as I have done so far. So let's move on to our second quadrant, because still there is some wonderful symmetry here. So we're adding 30, so we get 120. And then we have 135 degrees and 150. And of course, down here at the bottom, we're at 180 degrees. Okay. Our radian angles, since they progress up as you go up the unit circle, right, 6, 4, 3, 2, they come down as you go down the unit circle. So over 3, over 4, over 6. Okay, lots of symmetry, right? The angles across from each other have the same denominator. So pi over 4, and right across from pi over 4 is another set of pi over 4s, and the pi over 3s are across from each other. Okay, wonderful symmetry that you just have to learn the symmetry rather than memorizing everything. Okay, so we have 2 pi on top, and then we have 3 pi, and then we have 5 pi. Because in the second quadrant, the numerator is always 1 less than the denominator. Okay, wonderful, wonderful symmetry and patterns. So in addition, our coordinates match up also. So the 60 is the same as the 45, this is the 120, the 45 is the same as the 135, and the 30 is the same as the 150. Okay, so when we learn the pattern, we don't have to do a whole lot of calculations every single time. You can just use the pattern, which is so much easier. But in the second quadrant, remember the x-coordinate is negative in all second quadrants, and the right coordinate is positive. Okay, so this is what those points would look like. It continues all the way around your circle using those same patterns with different positives and negatives. Okay, so today we're going to add in this coterminal business. Okay, remember a terminal, or the terminal side, is the side where the angle ends. So if we were going to make a 135-degree angle, that is your initial side, always the positive x-axis, and we would open up until we have our arrow pointing at the 135 degrees. Okay, so that would be a positive 3 pi over 4 radian, or 135-degree angle. Okay, now of course, what if I went all the way around the circle more than once and ended up at the same place? Okay, so these are coterminal angles. If I didn't do the swirly swirl down the middle, you probably wouldn't be able to tell which angle I just made. Okay, is it a 135-degree angle, or is it a 135 plus 360, which my brain tells me is 495 degrees? Okay, so 135 and 495 are coterminal, because their angles look the exact same if we didn't have the swirly swirl in the middle. Okay, so if you closed your eyes and I drew an angle, you would know whether it was 135 or 495. And you get a 50-50 chance of guessing it right. And y'all are good guessers. I've seen your test scores. You're great guessers. Okay, so what happens here is the coordinates on your unit circle for 495 are the same as the coordinates of your circle for 135. Okay, the coordinates are the exact same. So if our coordinates are negative root 2 over 2 and root 2 over 2, that means the coordinates at 495 are negative root 2 over 2 and root 2 over 2. Okay, coterminal, they have the exact same ending points. And since there's only one unit circle, no matter how many times you go around, if you end up at the same place, you have a coterminal angle. Okay, so we could also make negative coterminal angles and go in the opposite direction, which is usually fun. So if you went in the negative direction, which is coming down this way, okay, this would be a negative, let's see, 225-degree angle, I believe, would get us right there. So the coordinate points at negative 225 would also be negative root 2 over 2 and root 2 over 2. So we can have positive coterminal angles and negative coterminal angles. So for every time you're given an angle, like say, I don't know, 2 pi over 3. Okay, so 2 pi over 3, hopefully you know, is a second quadrant angle. Something like this. Okay, so to find a positive coterminal angle to 2 pi over 3, we simply have to go around your circle one more time. Okay, in other words, we're going to add 2 pi to our given angle. Okay, this is one way that we can find another positive radian angle measure that has the same as 2 pi over 3. So we're going to change this so that our denominators are the same. So 2 pi is the same as 6 pi over 3, because 6 divided by 3 is 2. So whenever we're adding 2 pi to a fraction, we have to make sure to make them both into fractions. So then 6 plus 2 is 8 pi over 3. 8 pi over 3. That would be this angle where you go around your circle one time and end up at the same 2 pi over 3 angle measure, okay, coterminal. Now a negative one, if we went into a negative direction, that would be coming this way. Okay, we're going to subtract 2 pi from our given radian angle. So 2 pi over 3 minus 2 pi. Once again, we have to change our 2 pi into 6 pi over 3 so that the denominators match. Right? We can't subtract a fraction from a number or a number from a fraction without the denominators matching. So 2 minus 4 is negative 4 pi. Sorry, 2 minus 6 is negative 4 pi over 3. So this would be a negative angle that is coterminal with 2 pi over 3. And this green one is a positive angle that is coterminal with 2 pi over 3. Okay, and what's important here is that the sign at 2 pi over 3 would be the same value as the sign at 8 pi over 3 would be the same value as the sign at negative 4 pi over 3. The answer to all of these are the same thing. Okay, and that's the y value at 2 pi over 3, which is 1/2. So all of these have the same answer. All these answers are 1/2. Okay, because sometimes we get crazy and we give you angles in more than just normal unit circle angles. So you have to be able to convert your more than unit circle angle into a unit circle angle so that we can then use the coordinates from our unit circle to find the sine and the cosine and the tangent, as well as the cosecant, secant, and cotangent. Okay, that is all. Hopefully you got smarter.